So in this section, what we're going to be looking at is significant figures. Now, significant figures seem kind of random and kind of weird, but the truth is that they really, really are important. The reason that they're important is because anytime we measure anything, there's always going to be some degree of uncertainty. Now, how much uncertainty exists depends on the precision of the measuring device that you use. For example, we've got some tools below that are used to measure volume. I've got a beaker, an Erlenmeyer flask, a graduated cylinder, a volumetric flask, and this is really hard to see, it's actually a volumetric pipette. Now, if I was told to measure out about 50 milliliters of something, or about 100 milliliters of something, maybe I'll use the beaker, that's fine. But beakers are very, very, very inaccurate. If you look at the scale on the beaker, I know that I've got 500 milliliters here. There's a line 400 milliliters here. So I'm counting by 50s. Anything between those lines is an estimate. I know that I have about 400 or about 450. If I'm in between, I'm going to have to estimate a lot. If I look at my Erlenmeyer flask, on the other hand, I'm counting 20, 30, 40, 50. So now I'm counting by tens. There's a lot less uncertainty here. If I'm using my graduated cylinder, most graduated cylinders either go up by ones or even some go up by 0.1. So that's going to be a lot more accurate. So depending on your measuring tool, you're going to have better results. Now, I use that word accuracy. Accuracy is how close a measurement is to the true value. Now, you'll always see these same diagrams of the bullseyes. Accuracy, I'm trying to hit the center target. The closer I am to the center target, the more accurate I am. Okay? Now, precision is how close a series of measurements are to each other. If I take a single measurement, it can never be precise. Precision is a group of measurements. Okay? I have to compare a group of measurements to each other. Now, if I look at this first target, none of the arrows are close to the bullseye, so they're not accurate. None of these arrows, or actually I think they're probably darts, are close to each other, so they are not precise. My first diagram is not accurate, and it is also not precise. My second picture, I'm still nowhere near that bullseye, so I'm not accurate. But look here, all of these darts are close together, so they are very precise. Now, my third is what I really want. All of the arrows or darts are close to the center bullseye, and they're all close to each other. Now, I need my measurements to be both accurate and precise, because if I take 5 measurements and one is accurate, but the rest are all over the place, it's not going to help. I need all of my measurements to be the same each time, and I want all of those measurements to be close to the accurate or close to the true value. Okay? So here we've actually got some data that we can look at. Now, the true value is 25 milliliters. Okay? Or sorry. This is just showing how things are different. So here we've got our graduated cylinder. When I'm measuring the graduated cylinder, it's saying that there are 25 milliliters each time. A burette is a tool that we'll use later on in the semester. If you look, the burette, instead of having 25 milliliters, it's actually 26, 26.54, 26.51, 26.60. If you notice, there's a lot more information given to me from the burette. So my measurements here are a lot more precise because they're a lot closer together. Well, sorry, this is actually more precise, but odds are these are more accurate and they're also precise. Okay? Now, when we talk about measurements, we have to talk about something called significant figures. Significant figures only apply to measurements or they apply to calculations that are based on measurements. Now, significant figures are going to include all of the known values, so everything that I'm able to see, plus one estimated value. So if I were to look back at the data above, all of the known values would be the first numbers, 26.5. This tells me that my burette counts by 0.1. The 4, the 1, the 0, the 9, all of those numbers in the last spot, these are my estimates. Now, most people, when they use a measuring tool, they're going to tell me exactly what the measuring tool reads. They'll say, oh, it's 26.5, but they forget that estimate. Now, if it's not on the line, people tend to remember a little bit better. But even if it's exactly on the line, I need to say it's 26.60. I need to tell people that that measurement is right on the line. I need to show that estimate, okay? Now, here are some rules for counting sig figs and how to tell. It talks about leading zeros, captive zeros. There's an easier way to do that, so I'll talk about that in a second. I like the easy way better. If this works for you, use this system, okay? Now, the important thing from this little box to remember, exact numbers do not have significant figures. So for example, if I say I have 32 students in a class, it's exactly 32. I don't have 0.5 of a student somewhere. I have exactly 32. So I don't just have two significant figures in that measurement. I have 32.00000 for infinity students. So exact numbers have an infinite number of significant figures. So we don't use exact numbers to determine significant figures, okay? We're only going to use our measurements to determine significant figures, okay? So they've got their leading zeros, trailing zeros, captive zeros method. The easier way that I've found for students to remember is the Atlantic Pacific method. So if I've got my United States, the Pacific Ocean's over here, the Atlantic Ocean's over here. Okay, so, whoops, wrong way, there we go. Here's the way that this works, okay? If a decimal place is absent, absent starts with an A, Atlantic starts with an A. So if there is no decimal, I'm going to start on the Atlantic side or the right side, because the Atlantic Ocean is over on this right side. I'm going to start on the right side of my number. Now, I'm not going to start counting until I hit my first non-zero number. Whoops, it already has number there. Okay, so I want to start on the right side. Well, 5 is a non-zero number, so I start counting on my 5. I count all the way to the end of my number, so it has 1, 2, 3 sig figs. Okay, again, decimal point is absent. I start on the, oh sorry, I did that backwards. Ignore that. So I start on the right side. I can tell my left from my right, I promise. I start on my right side, I don't start counting until I hit my first non-zero number. 5 is my first non-zero number. So I don't start counting until I hit my 5. I count all the way to the end. I have 1 significant figure. Again, the decimal point is absent. I start counting on the right side. I don't start counting until I hit my first non-zero number. Again, it's a 5. I'm going to start at the 5, count all the way to the end. 1, 2. I have 2 significant figures. Here, no decimal point. I start on the right side. I don't start counting until I hit my first non-zero number. I count all the way to the end. 1, 2, 3, 4. This has 4 significant figures. Okay. If there is a decimal point present, P for present, P for Pacific. Okay? So if there is a decimal point, you start on the left side of the number. This time I start on the left. Again, I don't start counting until I hit my first non-zero number. And then I count all the way to the end. So this time, I start on the left side. My first non-zero number is the 5. So I go 1, 2, 3, 4, all the way to the end. I have 4 sig figs. Decimal point is present. I start on the left side. I don't start counting until I hit my first non-zero number. 1, 2, 3 sig figs. Okay? Again, decimal point is present. I start on the left side, the Pacific side. I don't start counting until I hit my first non-zero number. I count all the way to the end. 1, 2, 3. Again, I have 3 sig figs. So sig figs are going to be really important when we start talking about calculations. They're going to be very important when we do measurements for labs. So it's important you know how many significant figures there are in a measurement. Okay? If the decimal point is present, P, start on the left side of your measurement. If the decimal point is absent, A, start on the right side.